bond making and breaking in chemical reactions. Consider a chemical reaction of a diatomic gas hydrogen, H2, reacting with another gas, O2, to form a product, H2O. Each gas molecule of H2 has two hydrogen atoms bonded together. In Chapter 3, we studied that atoms form bonds to reduce their total chemical potential energy. Recall the potential energy diagram that we used to explain bonding. When the atomic nuclei of the two hydrogen atoms are at a particular distance, a bond is formed and the potential energy of the system is at a minimum. This distance at which the potential energy is at a minimum is called the bond length. The energy needed to separate the two atoms is called the bond energy. Note that this energy must be supplied to the system in order to break the bond. For this reaction to happen, the bond in the molecule H2 has to be broken to give two atoms of hydrogen. Likewise, the bond between the atoms in the molecule O2 has to be broken to give two atoms of oxygen. Bond breaking requires energy. Since the system goes from a chemically stable state of lower potential energy to an unstable state of higher potential energy. Bond breaking is therefore endothermic. Two atoms of hydrogen now form a bond with atom oxygen to give the product H2O. Bond formation releases energy, since the system goes from a chemically unstable state of higher energy to a chemically stable state of lower energy. Bond formation is therefore exothermic. All energy changes that occur in chemical reactions are based on bond formation and bond breaking. In this particular reaction, the total energy released from bond formation is greater than the total energy required to break bonds. Therefore, the reaction is exothermic. In the reaction of potassium nitrate with water, the total energy released from bond formation is lesser than the total energy required to break bonds. Therefore, the reaction is endothermic.
Starting to feel it? Now go master it with